Do ChatGPT and hacking passwords have anything at all in common? Isn't it that GPT is only for doing creative tasks or as a business tool? Only just things like that, right? Why then does this popular website from Hive Systems specifically mention ChatGPT as the fastest option by far for hacking passwords, as you can see here, for example? Let's dig into this. First of all, you might have seen this table in the past. It's widely cited, and it was just updated, by the way. This is the latest version. Here's the context. There are good guys and bad guys in the world of IT. The bad guys want to guess or steal our passwords, and the good guys work pretty hard at making that difficult to do. One thing the good guys do is hashing, which is a way of transforming an actual password into something a hacker can't use, even if he gets access to the database with all the hash codes in it. The code might look like this, for example. In fact, what you're looking at there is actually a well-known hash code. Many hackers might recognize this as the hash code for the word password, as encoded by a method called MD5. And that fact suggests a big problem, by the way, with some kinds of hashing methods. Partly for that reason, MD5 has been losing popularity in recent years in favor of other methods, like Bcrypt, for example. Bcrypt is an alternative hashing function that uses something called salting, which adds a random string to the password before it's hashed. So that way, even if two users have the same password, the hashed version of their passwords will still be different, which is clearly better than MD5. And in the other corner are the bad guys. One thing they're known for doing is cracking, as in cracking a code. One way they do this is to make a list of all the combinations of characters on the keyboard for each password length. And then they hash each of those combinations using various algorithms like MD5 or Bcrypt. Then they look for a match between one of the results they've generated and a breached database containing hashed passwords. And if the hashes match, then they already know the original password. So now they're in your account doing bad things. On the other side, there's something called Hashcat, which is used by IT security and people who do penetration testing. Basically, they're trying to do cracking too. But their purpose is to find weaknesses and correct them proactively. And for that, there's a professional community that shares test results and benchmarks. And that's how tables like this one are made. As you can see, the assumption for this table is that Bcrypt was used for hashing, and the notes tell us that they used 32 iterations, which is a good parameter. But what hardware were they using? Faster hardware, faster cracking. For the hardware, the table assumes 12 NVIDIA graphics cards, specifically 12 RTX 4090 GPUs. Those are high-performance GPUs. They're quite popular for gaming and also for deep learning, among other uses. Each of these has got 16,000 cores and can do 40 trillion floating point operations per second. So imagine 12 of those little fire plugs all working together in tandem. So here's that chart again. you can see that any password less than 8 characters gets tagged as red all the way across the table, regardless of whether it has uppercase, lowercase, or numbers and symbols. Starting with 8 characters, things improve, as you can see here. 7 years to crack a password if it has everything, including symbols. And that's if a hacker's using a dozen RTX 4090s. Not too bad. It takes that long because, as we noted, the Bcrypt algorithm was created using 32 iterations, which is specifically designed to make cracking time-consuming and expensive. But here's where ChatGPT comes in. Look at this. 7 years just became less than a week? What happened? First, you can see that now we're looking at NVIDIA A100s. Those are tensor core GPUs. They're for high-performance computing like machine learning and AI. Basically, Hive Systems calculated how long it would take to crack that same password if those 12 consumer-grade GPUs were replaced by A100s. 10,000 of them. Well, that's an enormous amount of computing power. To give an idea, it's been estimated that the GPT-4 model was trained on about 25,000 A100s for about 100 days. So, if that assumption is true, then this would be like having 5 days of access to about 40% of the compute power that created GPT-4. And that explains the connection to ChatGPT. It's just a way of describing a type of cloud-based situation where you might see a huge amount of computing power all together. But it is useful to see this. The point that Hive wanted to make is that no system is invincible. The best that any of us can do is to try to ensure that, as a target, we're just not worth the effort. By the way, I should mention that I landed on the Hive website again last week as a result of a conversation with this guy, Dave Stern. He just published a great book, Hack-Proof Your Startup, which you can see here. In fact, I'll be interviewing Dave this week as one of the first guests for a new podcast that launches on July 7, the AI Master Group. So, if you're interested in AI, I think you'll like the show. I'll leave a note in the comments with more information about the new podcast. Meanwhile, let's keep all those hackers in check, and may the G-Force be with you.